Hello, welcome to Programming with Purpose with Python, number 4. This is where we're going to develop a graphical user interface for the passer rating calculator that we started in previous slideshow. So we're going to develop our GUI in this slideshow, and we're going to learn about a new widget called a spinbox widget. We'll also do a little bit of coloring with the widgets, and we'll introduce error trapping into our application. And we'll finish with some more information about how you can learn Python. You are going to need the code from Programming on Purpose number 3, because that's what we're going to start with. And of course, for all these slideshows, you need to have Python 3 installed and tkintertoy installed. The conventions are going to be same as the other slideshows. Code will be in a monospaced text. New code will be highlighted. Objects will be in bold rounded text. And new words that I introduce will be in italics. GUI interfaces are very important these days. The modern world does not use command line interfaces. And Python supports many GUI libraries for that reason. The most popular one, or the one that comes with Python, I should say, is tkinter. And that is the interface to the tk-tcl library, and it is included in most installations. However, working with tkinter, while it's not extremely difficult, it's a bit much for a newer programmer. So I developed a library that sits on top of that, tkintertoy, that it makes working with tkinter even easier. And of course, like Python, tkintertoy is free. So here's the interface to the passer function. We need 5 input widgets and 1 output widget. We're going to need 2 command buttons, OK and cancel. And similar to the second version of the discount calculator that we developed, we're going to place all our input widgets on the left. Our 1 output widget will be on the right, and we're going to separate the two using a vertical line. So here is our design. You can see we have our 5 input widgets. The top 3 will be entry widgets, which we already know how to work with. And then we're going to introduce 2 new types called spin boxes. And over to the right, we'll have our label. And we'll have our vertical line and our 2 buttons, command buttons, at the bottom centered. Now, with every tkintertoy program, you must have this first line near the top. From tkintertoy, import window. Window is an object that is used in tkintertoy that kind of contains everything. So again, place this near the top, maybe right underneath the documentation line. Here's what we have to do to create our GUI. Our function is going to have to create a window, and then we'll set the title of the window. Remember, if you don't do this step, your title will default to TK. Then we're going to add our 3 entry widgets, and then our new 2 spinbox widgets. We'll add our vertical line, then add the label, add the command buttons. We'll plot everything, and then the very last line will be returning the GUI. Here's our new function. We're going to call it passer GUI. We have an empty argument list and that colon. And we have a little bit of documentation on the function. You can see we've switched to triple quotes for functions documentation because we're going to start doing multi-line function documentation, and we just need to get used to doing triple quotes. So very first line is we create our GUI just by calling the window object. and assigning it to the GUI. And then here we're setting our title to NFL Passer Rating Calculator version 1. Now we add our 3 entry widgets, and we're going to use the width parameter to make sure that all the entry widgets are limited to just 10 characters wide. So now it's time to talk about other widgets. The entry widget was designed to input strings or floating point numbers. But for small integers, there's a better widget, and it's called a spinbox. So let's use a spinbox for touchdowns and interceptions because usually you don't have a lot of those in any particular game. Now, you wouldn't want to use a spinbox for over the entry widget for the passes and the yards because, again, it's good for small integers. So here is our method that you have to use for adding a spin box. It's just add spin. And it's a little more complicated than the other widgets. We have to have a tag. Remember, everything in TK Intertoy will have a tag. And then you have something called parameters. And these are the parameters of the spin box. And then a little string called between. That will be usually a single character that is between the boxes. And then the prompt is the frame title. And we also have the optional keywords. So let's look at some examples of some spin boxes. The parameters is how TK Intertoy knows how to construct your spin box. It is a list of lists. And so the first element in the list is the width of the box, how many characters wide. And then you have a minimum value to display and a maximum value to display. So let's look at an example here. We're going to create a spin box for when you enter time. So it's going to be parms time. And you can see it's a list of 3 lists. And each element in the internal list tells exactly how those boxes are to go. So for time, we want the first box to be 2 characters wide, starting at 0 and ending at 23. Of course, that was what you would expect for a 24-hour clock. The next box is 2 characters wide, starting at 0 and ending at 59. And of course, that's going to be for the minutes. And then the last one, 2 characters wide, starting at 0, ending at 59. That will be for the seconds. So once you have that list of lists set up, so now you just call add spin, and the tag we're going to use is time. And here's where you use that parameter, parms time. And here you can see how the between string works. You can see the colon is in between the 3 boxes. And that makes sense because we're dealing with time. And of course, our prompt is current time. So below that, you can see we have a parameters for a date. And the first box is 2 characters wide, beginning with 1 and ending with 12. So that's your month. The next one is 2 characters wide, ending with 1 or beginning with 1 and ending with 31. And that is your day. And then the last one is 4 characters wide, starting with 2000, ending at 2100, and that is the year. And so the method call would be GUI add spin. Our tag is date. We have parms date, and you can see the between is going to be a slash, and the prompt will be current date. So you can see spin boxes are very useful for, again, restricting the user to make a certain entry. Our spin box is going to be very simple. We're only going to need 2 single spin boxes for touchdowns and interceptions. Our width will be 4, our minimum will be 0, and our maximum will be 99. So notice box parms is going to be, again, a list of lists. It has to have a list of a single list, and the width will be 4, the minimum value will be 0, and the maximum value will be 99. And you can see we did it for touchdowns, and we also are going to do it for interceptions. Notice the same parameters will work for both boxes. Now, we have something strange in that method. We have add spin, TD for our tag, box parms, and then we have to have that in-between string. But in this case, we don't really want anything there because there's only one box. So we're going to use an empty string, which is basically a quote right next to a quote. So empty strings are fairly common in computer programming, and you can use either single quotes or double quotes. Now, note the difference between an empty string, which is 2 single quotes, and a string that has a single space, which would be a quote, space, quote. An empty string will be logically interpreted as false. So now we're ready to add our 2 spinbox widgets in the code, and you've already seen that, so it shouldn't be any surprise to add this to our passer GUI function. So now we're ready to add our vertical line, and we're just going to give it a tag of line. And remember, lines usually are horizontal, so we have to have that orient optional argument that makes it a vertical. Now we're ready to add our label, and we're just going to call it rating because that's what's going to go in there. And our prompt for the user will be passer rating, and we're going to set its width equal to 10 also. And our command buttons, we're going to just call it command, and we're going to set the spaces between the buttons to 5 pixels. So now it's time to plot everything. And you remember, plots have lots of optional parameters. So if you can think of the widget space with the big rectangle on your screen, you can see that pad X will tell you how much space in pixels between widgets horizontally. Pad Y is the space between widgets vertically. And then that's sticky. Now normally the widget will go right into the center of the space that you designate, but you can put it in other areas based on a compass, where north would be above, south would be below, west would be to the left, east would be to the right, and you can also go for the corners as well. So we're going to plot the entry widgets, and we're going to use a 2-column layout, and we want these widgets all left aligned. So that's why we're going to go with sticky west. The other ones, parameters, are, you can see, are self-explanatory. We want a 5-pixel vertical spacing between the widgets, but 25 horizontal spacing. And again, the order of the optional arguments is not important as long as each one is labeled. So now we're going to plot the spinbox widgets, and notice, other than the row and the column, the other parameters are exactly the same. So that's the nice feature about plot, is it will plot any widget you come up with. You don't have to have specialized plot options for different types of widgets. So the vertical line, we're going to want that in the middle of the second column, so our column is going to be 1. It's going to be stretched across 5 rows, so that's why you see that row span. And we want to stretch it from top to bottom, sticky north to south. If we didn't have that sticky north to south, what you would see would be a little bitty line right in the middle of our box, because it's going to place things into the center, but it doesn't know to stretch it out. Even though you see the row span there, if you want it to actually span those rows, you have to use the sticky option. So now we're ready to plot the label widget. We want it in the third column, so that's going to be column 2. And we want it in the middle of the column. So now we're going to do the row span 5 there as well. Horizontal spacing of 25 pixels, vertical spacing of 5. And notice here we don't want sticky. We don't want to stretch that out. We just want it to be a 10 wide column label. So there's no need for the sticky option. We're ready to plot the command buttons. We want them in the middle. So that's why you see column span 3 and row 5. The vertical spacing is going to be 10. And again, we want these in the center. We don't want them stretched out, so that's why you don't see the sticky option. So our last line is return GUI, and you can see here's the complete GUI creation code, and it's all contained in one function, passer GUI. So now it's time to test the GUI. I want you to go into your code and remove that print command and replace it with this line near the end of the file. GUI equals passer GUI. Notice I'm using the camel case. If you created a function using the camel case, when you call the function, you have to use the exact same case. There's no arguments, so you just use an empty argument list. And this line must not be indented. Now, we are going to take this line and add it into a function later on. But for now, we don't want this line indented. So we run our application, and we can see there is our GUI. Now, it won't do anything yet, but this is a good place to see, do things line up, are they looking the way I want them to? So you can actually do a lot of how the GUI appears without actually writing any code for the final action of the GUI. So now we're going to use our GUI. After the user fills in the values and clicks on OK, we need to process that input. So we're going to create a function which we will call process OK. Now process OK will get the input from the user and convert it to an integer. Then we're going to call passer rating. Passer rating will give us a float, and we have to convert that into a string, and then we'll place that into the label widget. So here's our function, process OK, and it will have an argument or a parameter, and that will be the GUI. So we have the parameter in parentheses and that colon. So we have our documentation for the function. Then our first 3 lines, we assign comp, attempt, and yards, the results of GUI.get for each one of those tags, and then we convert it to an integer. Remember, GUI.get will return a string, so we need to convert it to an integer. Let's review the index operator. Remember, an index operator selects a single object out of a sequence. You count from 0, and if the index is negative, you count from the back. If the index is too large, that is an error. The reason why we need an index operator is because that's how get works. Unlike entry, when you use get with spinboxes, it returns a list of integers. So rather than convert the results to an integer, you have to use the index operator to get the particular integer you want. So, for example, if current time is what you see on the left, if we use get on that, we would return a list with 14, 30, and 15. So if we wanted the hour, we would have to use the index operator of 0. The minute would be index operator of 1, and the second will be index operator 2. For our examples, for the touchdowns, we're going to use the get, and it's still going to return a list of a single integer. So if we want that integer, we have to use the index operator of 0. So here's how we get the touchdowns and the interceptions. We're using GUI.get on the respected tag, but then we have to apply the index operator of 0. Again, you do not need the integer function. So now we're going to call passer rating, and it's what we expect. You just have passer rating, and our 5 parameters, or actually 5 arguments, and then it's going to assign the results into rating. Now when we have the result, we remember that is going to be a float, and to get it into the widget, we have to use the set method, and set will only accept strings. So we have to take the float that we get from passer rating, which we have assigned to rating, we have to convert it into a string and then call the GUI.set method. So here is our complete function, and this function has no return, because really what it's doing is basically it's setting a value into the widget as its final action. There's no need for it to return anything. If you were to look at this function and assign it a value, though, you would see that it actually returns the none object. That can be a problem if you're not careful. So when we call process OK, you're going to see we don't assign it to anything. So now it's time for our main function. And as we found out before, most applications have a main, and it is the driving function of the application. We've already done most of the work, so our main is going to be small. So in our main, we're going to start with creating the GUI, and then we will begin an infinite loop. Then we're going to do a event loop where we'll wait for the user to press a command button. If the user presses the OK, then we'll call process OK. And if the user presses cancel, then we'll break out of the loop, which will end the application. So here's our main. And remember I said that we would be using that GUI equals passer GUI. Well, here's where you use it. And here's where you do have to indent it. So a quick review of infinite loops. That is an example of what's called a conditional loop in Python. So it's just while condition, colon, and your block of code, which is indented, and you might have an optional else clause. And to get out of these loops, you use the break command. So an infinite loop is a conditional loop, but it's set to true. So while true, and notice true is capitalized, and that colon. So this loop's going to run forever. So we have our block of code, but then we also have if condition, colon, break. And this is what's going to break out of the loop. By the way, this type of coding is very common and very useful. So here we begin our infinite loop, just while true, true's capitalized, with that colon. Everything underneath that is going to be indented. So we want the user to do all his actions and then click on a button. That is our event loop. And in tk-entertoy, the method is GUI.waitForUser. So that will run continuously, updating all the GUI, all the stuff it needs to do until the user clicks on one of those command buttons. Now, if the user clicks on OK, then GUI.content will contain the contents of the GUI. And so if that is positive or true, then we want to run process OK because we know the user clicked on the OK button. And of course, when you call process OK, it has to be indented under the if statement, and the argument has to be the GUI. Now, if the user clicks on else, then GUI.content will be empty. So all we have to do is say else : break. And again, break must be indented. So here's our complete code for main. And you can see it's short, very direct, because most of the work is done in the functions. So now we have to call main, and it's common in Python to write a script that runs main if it's executing, but does not run main if it's importing. So most Python scripts have this code at the bottom, and it's very funny looking, but it makes sense if you know what's going on behind the scenes. If underscore underscore name underscore underscore double equals quote underscore underscore main underscore underscore quote, that's a string, colon, then call main. So again, if you're running this script from the command line, it will run because name will be main. But if you're importing, then it will not. And the underscore underscore word underscore underscore has a very special meaning in Python. When we get into more advanced programmings, we'll see some other examples. So here is our complete application. You can see we have the from tk-entertoy import window. Then we have our definitions of filter term, passer rating, the passer GUI, process OK, the main, and then we have our code that actually does anything. If underscore underscore name underscore underscore double equals quote underscore underscore main underscore underscore quote colon run main. We test it and voila, it works. So here's an example of what we developed earlier, showing that the math still works. So we should feel very pleased that we have an honest-to-goodness GUI application that can calculate the NFL passer ratings. So our application works, but since this is our third application, let's have a little fun and play with some font colors. tk-entertoy calls the font color the foreground. So to change foreground colors, all we need to do is add a keyword argument to the spinbox creation method. Now, entry font colors are actually controlled by the operating system, and these are quite a bit more difficult to change. Now, the colors in tk-entertoy are based on the TK library, and as you can see, the number of colors is almost mind-boggling. About any color you can think of is going to be listed in this chart. You can also type in what's called the RGB tuple, which stands for red, green, blue. So it turns out there's about 16 million possible choices. So your application should be able to come up with any color that you desire. So adding colors to our GUI, we want to make the touchdowns thrown spin box to have green text and the interceptions thrown spin box to have red text. Let's start simple. If you want to get fancier, feel free to go ahead and choose a different color. So, as I said, it's really quite simple. All you have to do is in the GUI.addSpin method, just add in a foreground keyword argument. So in this case, for our touchdowns, we added in foreground equals green. And notice green is a string. So that's it. So for our touchdowns, we have foreground equals green. For our interceptions, we have foreground equals red. So 2 minor changes, and now we will have color in our application. So here's the result. And indeed, you can see for the thrown touchdowns, our font is green. And notice the up and down arrows are also green. It's a nice little feature to the widget. So really, the only change we had to make was to the passer GUI function, and those changes were minor. So don't be afraid to experiment with colors. We are almost done, but we need to let our user know if they make a mistake when they enter in data. This is called error trapping, and all good applications should have it. Right now, if our user types in a bad value, like 40s instead of 40, and he clicks on OK, nothing seems to happen. The application doesn't crash, but again, you don't actually see anything. If you look in the shell window, though, you will see something called a traceback for something called value error. And at the very end, you can see the message says invalid literal for integer with base 10, 40s. So there's your error message. So we need to capture this and give our user something a little more useful to go on. So our application has raised in Python what is called an exception. And our particular exception is value error. Notice that value error is camel case. Now this happened when the application tried to convert the string 40s into an integer. And it is quite easy to trap these exceptions and warn the user by using a new construct which is called try except. And this is how it looks. You have the word try with a colon. Again, don't forget that colon. And then you have a block of code which is indented that could cause a problem. Then after your block of code, unindented, you have except and all the exceptions that you're trying to trap, and then a new block of code underneath it that is indented that tells it what to do if the exception occurred underneath the first try. So here's an example. We should have try colon and then indented att equals an integer of GUI.get att. And let's say the user types in an invalid value, then that's going to execute what is under the except value error colon. And right now we just have print error, which would just show up in the shell window. So rather than printing an error message in the shell, let's write an error message in the label widget. And we're going to make it quite simple this time. We're just going to say GUI.set in the rating widget input, and we'll put a little question mark on there. And notice input is a string, so it will just pop up there whenever the user makes this particular error. So the way to do that is to change the process OK function. So we're going to take our current lines, and they're going to have to be included into a try except block. So those lines have to be indented. And if you remember, idle makes this quite easy. All you have to do is highlight the lines that you want to indent and then use Format, Indent Region. So here are the changes we have to make to process OK. We added in our try statement. And then our existing code, we just indented it 4 spaces. And then we added in the accept value error. And then what we want our error trapping to do, in this case, it's just print into the rating widget input with a question mark. Now here's where you have to be a little bit careful. I know it's tempting to write in something funny, but your user could be quite irritated if you get too clever. So it's just best to keep things simple. So here we're testing it, and notice we typed in for attempted passes 40S, and the message is input under the passer rating. So that gives our user, letting them know that they made an error somewhere. Now we could be more sophisticated and say input in attempted passes, but that's a bit much for this level. We might implement that later on. So as you can see, it is pretty easy to add error trapping to any type of application. The only function we needed to change was process OK. And your user will thank you if you have good error trapping. So here's our final application. You can see we have the from TK Intertoy import window, the definitions of filter term, passer rating, and passer GUI, and then our new process OK and main, and finally that weird code at the end that calls main. So by creating this little application, we've learned quite a bit more Python. And if you find this application useful, if you go back to the earlier slideshows, you can create a shortcut and have this on your computer so you can get to it. For our next lesson, we're going to create an application that is a digital stopwatch, and we'll learn more Python. Until then, enjoy playing with Python. TinkerToy is hosted at this website, and the documentation for it can be found at another website. But the easiest way to get to it is basically just Google TK Intertoy. If you live in or near southern Indiana or the Louisville, Kentucky area, I teach 2-hour free seminars at the Jeffersonville and the New Albany Public Libraries. And the classes are small, and we use the hardware that the library will supply, and we go through these slides with me standing beside you and helping you out if you have any problems. So if you think you would like to experience these slides in a live setting, just call or go online to reserve your spot. Thank you for listening. If you enjoy these little slideshows, be sure to subscribe and tell your friends if they want to learn how to code in Python. Till next time, happy coding.